Hi students, MCQ 23. Two identical capacitors having the same capacitance C, one of them is charged to potential V1 and the other to potential V2. The negative ends of the capacitors are connected together. When the positive ends are also connected together, then the decrease in energy of the combined system has to be determined. This same question itself has been asked many times in the previous year in medical and engineering entrance examinations. Such a very important numerical problem which can be done in two methods. Already I told you at the beginning stage, you are a learner, learn both the methods. Now, by the first method, you look at the situation given here. The first capacitor is having a capacitance C and it is charged to a potential V1. Okay, so its energy, its potential energy is half C into V1 square. And the second capacitor is also having the same capacity C and the potential is what? V2. Okay, so the energy of the second capacitor is half into C into V2 square. So what is the total energy of the system separately? Total energy of the system U initial. So here U initial, I will take U initial is equal to half into C V1 square plus half into C V2 square. So this is equal to C by 2 into V1 square plus V2 square. This is the initial total energy of the two capacitors. What next is given? The positive terminals of the two capacitors are joined together and the negative terminals are joined together, means they are connected in parallel. They are connected in parallel, is it not? So C parallel is equal to C1 plus C2, that is equal to C plus C is equal to what? 2C. Okay, the combined capacitance in parallel is what? C plus C is 2C. But what will be the potential difference across the two plates? It's a new concept for us. Initially, before connecting, they had different potential differences V1 and V2. But now when they are joined together, they will attain a common potential difference. So the common potential I am going to use, okay? So the final energy, the energy of the system is equal to half into C parallel into common potential the whole square. The common potential is C1 V1 plus C2 V2 divided by C1 plus C2. This is called common potential. This formula is new to us, we have to remember. Okay, here both C1 and C2 and C2 both are same only, is it not? So this must be equal to what? U final must be equal to 1 by 2 into C parallel, what we have found already is 2C. So this is 2 capital C into C V1 square plus C V2 square. So C into V1 plus V2, okay, the whole square. Now denominator will come as what? C1 plus C2 is C plus C is equal to what? 2C. And this is the whole square. Okay, inside the bracket now this C can be cancelled. So this 2 and 2 get cancelled. So this is equal to C into V1 plus V2 by 2 the whole square. So this is V1 square plus V2 square plus 2V1 V2. Is it not? This denominator 2 square will come as 4. Understand that? So this is U final. C by 4 into V1 square plus V2 square plus 2V1 V2. That's nothing but V1 plus V2 the whole square only. Now what is asked here? The decrease in energy, that is delta U. Decrease in energy means U initial minus U final. So what is this U initial? U initial is half C V1 square plus half. So this is half C V1 square plus half C V2 square, okay, minus, you see here the first term, if you open up the bracket, 1 by 4 C V1 square will come, 1 by 4 C V1 square, understand that? And the next term will come as what? Minus 1 by 4 C into V2 square, minus, when you multiply C by 4 into 2 V1 V2, this 2 and 4 get cancelled, so that it will come as what? 1 by 2 into C into V1 V2, okay. Now you see here, half into C V1 square minus 1/4 of C V1 square, that will be equal to what? 1/4 of C into V1 square. Is it not that? So similarly, next term, half into C V2 square minus 1/4 of C V2 square will be what? Plus 1 by 4, okay. So this is half minus 1/4 is what? 1 by 4 into C V2 square. Okay, what next is coming? You see, the last term is minus 1 by 2 into C V1 V2. So this can be written as minus 1 by 2 into C V1 V2. Okay, therefore delta U, the decrease in energy, is equal to 1 by 4 C V1 square plus 1 by 4 into C into V2 square minus, I will take common factor as 1 by 4. So that 1 by 4, okay, 1 by 4 into C, I will take out. First term will become V1 square, second term will become plus V2 square, okay. So this will become V1 square plus V2 square minus half. Here 1 by 2 is there, I will make it as 1 by 4 as a common factor, means it will become 2 V1 V2. So this is 2 V1 V2. Okay, so this delta U, loss of energy, must be equal to 1 by 4 into C into V1 square plus V2 square minus 2 V1 V2 is what? V1 minus V2 the whole square. So this is V1 minus V2 the whole square. So this is method 1. By method 1 we have got the answer. So which is the correct option? You see here 1 by 4 C into V1 minus V2 the whole square. We get the same expression. So this is the correct answer by method 1. But in the competitive exam, if you go by this method, okay, it will take much time. It will take much time. So for that, one shortcut method is there. Method 2, directly loss of energy. Okay. So directly loss of energy can be found by another method, that is given by half into, okay, C1 C2 divided by C1 plus C2 into V1 minus V2 the whole square. This expression you have to be thorough. When two capacitors are connected in parallel like this, having different potential differences are connected, then the loss of energy is given by what? Delta U is equal to half into C1 C2 by C1 plus C2 into V1 minus V2 the whole square. This is the expression. Here C1 is equal to C2. Is it not? Both are having same capacitance. So this must be equal to what? 1 by 2 into C is C square divided by C plus C is 2C. Okay. Into V1 minus V2 the whole square. So if you cut this square with this term C, 1 by 2 into denominator 2 will make this as what? 1 by 4 and C into V1 minus V2 the whole square, and this is the second method, which is the direct method. This only you will have to practice. Such formulae are not in our syllabus textbook, it will not be found. So we have to prepare extra. Understand? So by both the methods, my dear students, what is the answer? 1 by 4C into V1 minus V2 the whole square. So which is the correct answer? Option C. Is it not? Therefore option C is the correct answer. I hope you must have understood well. Fine.